Okay, so this is the 2023 paper 1 question 11 on the topic of rate of change. So they tell you that there's a circular patch of water, negligible thickness. Okay, so you don't need to worry about the thickness. Okay, is expanding on a piece of paper. At time t, the rate of change of the radius is given by this equation, right? So they've given you your dr dt. Initially, the patch of the radius is 1 cm and is increasing at a rate of 0.5 cm per second. This is essentially your dr dt, because if you see by the units, this is the cm of your radius for every second. Okay, show that k is equals to 0.5. So all you need to do is just sub dr dt equals to 0.5 into your equation, in which this happens when time equals to 0. Right? Take note when time equals to 0. Because when time equals to 0, this is when initially. Right? Initially. So all we do is just k over 2 times 0 plus 1. Right? And we just cross multiply, we get our k to be equals to 0.5. Shown. Okay. Next one, they tell you find an expression of r in terms of t. So all we need to do is basically to integrate this. When we're integrating this, right, r equals to the integral of 2t plus 1 dt. Okay, and you learn for your integral of such fractions, right, it will naturally become ln, right, in which our ln, if you remember, for the integral of our ln to appear, right, for a ln to appear, we basically need to be integrating the differential to be at the top and my fx to be at the bottom to get my ln to be fx. So here what I'm going to do is I'm going to make this differential appear first. How do I do that? Well, at my denominator is 2t plus 1 dt. Right, the differential of this at the top needs it to be 2. But currently now I have k. Right, so we cannot change the meaning of that. We cannot change the k. So what we need to do is we need to compensate for it, for our k to be outside. And this will be over 2 over here. And here you will be able to see that, actually I didn't change the meaning of it. It's still k. But what I'm able to do is I'm able to get this to be in the form of my f prime x over fx. And as a result, this would integrate to give you k over 2 ln 2t plus 1. Okay, and don't forget we need to plus c over here because this is an indefinite integral, of which we will need to find our plus c. Okay, how to find the plus c? Well, we are given the boundary conditions over here, which is that when your time is equals to 0, you can see that your radius is equals to 1. So all we need to do is just sub this in. Right, sub it in. And we already have the k value as well. Later we're going to sub it in as well. K equals to 0.5. Right, so we sub it in. 1 equals to 0.5 over 2 ln 2 times 0 plus 1 plus c. Okay, and here you can easily see that this just basically becomes ln 1. Right, so this simplifies to give you 1/4. And ln 1, if you press your calculator, or if you already remembered it, ln 1 is just 0. So this term becomes 0. So my c is just equals to 1. Once you have your c to be equals to 1, we're going to rewrite our r expression out. R would be equals to, right, we need to sub in this value of k. So as earlier when we sub in k, right, 0.5 over 2, this thing just becomes 1/4 ln 2t plus 1 plus 1. Okay, so this is how you get the expression of your radius in terms of. Okay, and for part C, they're asking you for the rate of increase of our area after the patch has been expanding for 3 seconds. So this is when time equals to 3. And they're asking for our dA dt, right, rate of increase of area for time. Right, and dA dt can actually be expressed as my dA dr multiplied by my dr dt, because my dr dr can cancel out. right? And over here, we just need to find out what is my dA dr. We already have an equation for our dr dt, right? It's over here in the question that my dr dt is equals to k over 2t plus 1. So we first write that down. And we know our k value from earlier, it was 0.5. Our t is when time equals to 3, so we just sub that in, right? And we simplify this. I'm just going to get it to be 1 over 14. As for my dA dr, I need to know that dA dr is basically the differential of my area. And we know that the differential of our area in this case, our area is an area of a circle because it's a circular patch of water. So our area of circle is just pi r squared, right? And when we differentiate this, we just get it to be 2 pi r. And when does this happen? Well, it happens at a certain radius. And this radius just so happens that from our earlier part, we found it to be in terms of time. So what we need to do is to find this radius when time equals to 3. Right, when time equals to 3, our radius is, I'm just going to sub the 3 in here, 1/4 ln, this becomes 7 plus 1. Right? And all I need to do after I have this radius is I'm just going to sub it into my dA dr. Right, and now I have my dA dr, I have my dr dt. I'm ready to sub both of it into my dA dt. So for my increase of area with respect to time, it is thus my dA dr, which is 2 pi 1/4 ln 7 plus 1 multiplied by 1 over 14. So just press this in your calculator. And you will get your answer to be approximately 0.667 units square per second. Okay, second in terms of time, and our area, okay, they have given it to us as cm, so we will need to write this as cm square per second. And that is your answer for this question.